Welcome to the statistic learning session. Today, we'll explore mathematical principles behind testing hypotheses on random variables and pivotal statistics. This discussion emphasizes how pivotal distributions are computed without relying on unknown or known parameters, ensuring universal applicability across varying sample sizes. Now, let's dive into it. To do that, let's understand the goal. We aim to transform random variable xi using a function f0 such that results follows a uniform distribution unif 01 if xi has a cumulative distribution function CDF f0. So that's our goal. Now, under null hypothesis, what would happen under null hypothesis? Think about it. Under null hypothesis, f x I will follow a uniform distribution. It will follow uniform distribution, that is unif 01. Now, this means that applying f0 to x1 ensures uniform distribution. That's what I'm trying to say. Order uniform random variables. What does it mean? After we apply f0 xi, the resulting values are ordered in uniform random variables denoted by ui because f0 is an increasing function. The original xi values were ordered and their images remain ordered. That is, when we apply f0 to xi, whatever value it produces are also in order. Now, let's talk about distribution of ordered uniform random variables. If given n random variables, the smallest ordered variable has a distribution u1, second smallest variable has distribution u2, and so on. Now, this produces some random variables, ordered RVs. The first RV will have the u1, a ui as a random distribution. Second RV will have a u2 as a random distribution. Can you tell me how to compute these distributions? Think about it. We can compute ui by I divided by n and u I minus 1 by I minus I divided by n. That's how we compute it. This calculation does not depend on any additional parameters. Now, let's talk about computing the statistics Tn. Can you tell me how statistics Tn is computed? Think about it. The formula to compute statistic Tn is equal to supremum of f n t f not f0 t, where ft is a empirical distribution, while this is a true CTF. This measures the maximum absolute difference between f and t and f0 t. Now, let's talk about distribution of Tn. Tn has a pivotal distribution. Its distribution does not depend on any unknown or known parameters. For any n, pivotal status holes are true, making Tn universal. Now let's talk about critical values of Tn. Critical values need to be calculated for each n. When we compute critical values for distribution of Tn for various n. As n approaches infinity, distribution aligns with the supremum of absolute value of Brownian bridge. Now let's summarize what we learned today. In this presentation, we outlined a process of testing hypotheses and using pivotal statistics. By applying F0 to random variables, we achieved uniform distribution under null hypothesis. We examined how these ordered uniform random variables are distributed and computed the test statistics Tn, which plays a crucial role in hypothesis testing. Importantly, Tn is a pivotal nature, allows us to create or calculate critical values without relying on unknown parameters, making universe applicable across all sample sizes. So that's all for today. I'll see you next learning session. Thank you so much. Have a nice day.